Would everyone please stand and welcome the entering class of PhD graduate students at Case Western Reserve University School of Medicine. Please be seated. Good afternoon, students, faculty, parents, family, and friends. Welcome to Seeds of Discovery, our 7th annual PhD White Lab Coat ceremony at Case Western Reserve University. I'm Paul McDonald, the Associate Dean for Graduate Education in the School of Medicine, and I am thrilled to have you all here enjoying this beautiful day in Cleveland. This is our 7th year for this event, and so far, we have always been blessed with good weather, sunny days, and good temperatures. The sun literally shines on our students here at Case at Seeds of Discovery. This is our 7th, and this is a record, okay? We have nearly 100 students entering our PhD programs, and we have well over 200 family and friends here in attendance. Families that have traveled as far away as Washington State, California, Colorado, Texas, Florida, and even India and Germany. Parents have traveled to come here. Thank you all for being here. The purpose of Seeds of Discovery is to formally recognize and welcome this entering class of PhD graduate students as they begin their training in the profession of biomedical research. While hundreds of white coat ceremonies are held throughout the United States medical schools each year to recognize their medical students, Case Western Reserve University is one of only a handful of medical schools that also recognize their PhD students in this way. The title Seeds of Discovery is taken from a quote that is attributed to a famous 19th century American physicist, Joseph Henry. The seeds of great discovery are constantly floating around us, but they only take root in minds that are well prepared to receive them. This ceremony proclaims the value that our PhD students bring to the School of Medicine and the significance that these young scientists have in fulfilling the research mission of the School of Medicine, indeed the mission of the entire university. It also affirms our commitment to you, our colleagues, our young colleagues, to provide the best educational approaches, training experiences, mentoring relationships, and individualized skill development to lead to success in research-intensive professions. We are here together to celebrate this group of PhD students, a truly international, diverse, and accomplished collection of young scholars. We have 94 entering PhD programs in the School of Medicine, including 14 or so students from our MSDP program, the dual degree MD PhD program, and they are entering their first phase of the PhD training of that dual degree program. We have about 50-50 male to female students coming in. You come from 10 different countries, including China, India, Uganda, Saudi Arabia, Portugal, Egypt. You come from 24 different states. I named a few: California, Colorado, Montana. About 27 or so % of you come from the great state of Ohio. And indeed, 10% from our own outstanding undergraduate institution here at Case Western Reserve University. You come from other highly prestigious institutions, research intensive, Johns Hopkins, Duke, Harvard, Berkeley, Vanderbilt, many others. Your GPA is about 3.7 on average or so. Your GREs are in the 75th percentile. You come with at least 2 years or so on average of really intense research accomplishments. Clearly an accomplished group of brilliant, creative young scientists beginning the program. I hope this is an exciting day for you. I know it's an exciting day for me and for the entire school. I love this event. I love this day. It is truly a day to enjoy and celebrate not only our new students, but all of our students, our faculty, our staff, and our leaders here at this amazing educational and research enterprise that is Case Western Reserve University. And so welcome, everyone. And now, on with the program. It is my great pleasure to introduce Dr. Mark Chance, the Vice Dean for Research in the School of Medicine and the Charles W. and Iona A. Mathias Professor of Cancer Research. Mark.
Welcome to you all. Thanks to Paul. I'm very privileged to be involved in the graduate education administration and work with the chairs and with Paul and Cheryl Thompson to make sure that you get the best possible opportunities in education you can. Especially, I want to recognize the chairs and the graduate program directors that are attending and participating in Seeds of Discovery. These are some of our greatest minds in the nation and some of the busiest people in the world. So the fact that they're here and those folks will help you into your white lab coats shows you where their priorities lie, right? This is the most important thing they can be doing, and they're here right now doing it. I want to welcome the faculty in attendance. Your dedication, your mentorship, your enthusiasm, your passion for the research enterprise are key ingredients that nurture these young scientists and are instrumental for their continued growth and development. But there's somebody else I want to recognize. It's all of you who have come here today to recognize and be part of what your children, your sisters or brothers, your parents, your cousins, all of the friends, familial relationships that are represented today. Paul said briefly all of the thousands and tens of thousands of miles that were traveled by all of you to come here. I hope you would stand up for a second. I think your students need to recognize you. Could you stand up and be recognized? All the visitors here today, please stand up. Please stand up. Thank you for that moment. Now, I want to tell you a little bit of what I told them. They've probably heard from me already. When we were visiting the university, we worked hard to convince them this was the right place to be. And I had the job of saying, this place will fit your values. This place will be part of your future. So why is that? Why is that? Because the missions of the medical school are so straightforward and clear for us to think about and aspire to. Excellence in education. Every training program has to have that hallmark. Research that has an impact in our local community. So you may be doing research that identifies how a SNAP coupon can be connected to a farm market to test whether we can improve wellness in families who don't have access to grocery stores. You may do sequencing of African American versus Asian versus European ancestry populations to understand what are the heterogeneities that make response to cancer different. The third thing, so that's the research in the community. The third thing is basic science research at the pinnacle of the nation, and an eye to translating that basic science for the benefit of patients, to positively impact society. And I'll just close on a note, increasingly, that impact is of a cure agenda, not treating disease, eradicating it. Your children, your cousins, your brothers and sisters, that's what they're gonna do. And I'm so excited to be a part of it. Thank you so much for coming today.
Thank you very much, Dr. Chance. Now we have a special guest speaker this year. Dr. Timothy Miller earned his doctoral degree in pharmacology from none other than Case Western Reserve University. That was about 10 years ago, plus or minus. He is an established entrepreneur who co-founded his own gene therapy company, Abiona Therapeutics, with a research building just a stone's throw away from where we sit today. Abiona Therapeutics is a publicly traded firm that recently surpassed the valuation of $1 billion on the market. I'm very pleased to introduce one of our most distinguished young alumni, Tim Miller, President and Chief Scientific Officer of Abiona Therapeutics.
Thanks. You know, when Paul asked me to come in and talk, I thought we were actually going to watch a Star Trek movie with Seeds of Discovery. That's kind of what I thought the relationship was. So, but on that note, when we started thinking about the Seeds of Discovery, it really got back to some of the things that are more in our popular culture right now, which is superheroes. So just a show of hands, DC fans. If you're a DC fan, all right, yeah, I see a couple. If you're a Marvel fan, everybody knows Marvel right now, of course, Marvel, right? And certainly the X-Men, fit into that as well. So I'm a fan of Captain America, personally, partially because science helped create him, right? And that also relates to some of the X-Men and their mutant genes. And so I wanted to tell you just a little bit about my backstory. So I came to Cleveland in 1990, did a bachelor's and a master's at John Carroll. I was a kind of crazy double major in biology and medieval and Renaissance studies. So you can actually you had to make a choice, right? So no more D&D. So I worked for a while in academia for a little bit, then I went into biotech. I came back to do my PhD in the wonderful Department of Pharmacology, where back then the white coat ceremony was a bag of Doritos and actually a Goodman and Gilman Bible. It was about this thick, so for those medical students as well. But then I graduated with my PhD and got into a couple of gene therapy companies, and learned kind of as you moved through the different roles at a gene therapy company, how you do regulatory and how you do manufacturing and how you get into clinical trials. And really what brought me back to was my PhD. And so Paul mentioned that I did my PhD with Pam Davis, which is a cystic fibrosis lab. So while going through my PhD, we went into the clinic and we met a bunch of kids with CF. And that imprints on you very, very profoundly, because when you're doing your PhD and you're trying to work on science, in many cases, you're trying to discover new drugs. And those are drugs that are going to really have a meaningful impact on some patients' lives, you hope. So when I finished my PhD, I got into some of these biotech companies, and I started looking around at different science, and I found this really, really amazing gene therapy program out of Nationwide Children's Hospital. And one of the things you're going to be trained here at Case in your PhD program is how to think and how to recognize really good science. And as a person, part of your job is how to translate that science into good clinical or good products for the benefit of humankind. So while I was there, I met a bunch of rare disease families, and it reminded me back to my days of when I was working on cystic fibrosis. And these are truly devastating, horrible diseases where children progress 2 or 3 years normally, and then they spend the next 10 to 15 years regressing, and 70% of them don't reach the age of 18. So I thought to myself, wow, this is really some impressive science. How can I help get this into the clinic, and how can I help move it into a product? So again, this really imprints on you when you're trying to do some of the science. And as you think about, well, what are the things that I need to learn to be able to get to those next steps? Here's what Case is going to help you with, and here's what your PhD mentors are going to help as well. So at Abeona, our theme is working together to find a cure. And in the past 3 years have been the first ever gene therapy approvals. These are truly Lazarus drugs where you're able to see, for those of you that have heard of a company called Avexis or spinal muscular atrophy, these children are born and basically spend the first 2 years of their life in a hospital. These drugs, after one single treatment of this gene therapy, they're able to get up and walk and talk and lead a semi-normal life. And so as you're thinking about what drives you, find your superhero. Find what it is that's going to get you back to the bench at 11 o'clock at night, okay, when you got to go back and develop a Western blot, or you got to go back and read, some qPCR. These are the things that, help you, because hold on to that. Find it and hold on to it. And I would encourage all of you, if you want, to come down to Abeona. We are literally right down the street. Come and take a look and see what the future of genetic medicine can look like. And I'll leave you with just one thing, what I call the sneeze analogy. So if the person next to you sneezes and has a viral cold, they're going to release about 100,000 viral particles. And you're going to look at that person and think about them the next couple of days and say, thanks a lot. You got me sick, right? So we have been able at Abeona to build a manufacturing facility to make some of these first ever gene therapies. To give the same amount of drug in a 15 to 20 minute infusion, you would have to sneeze 10 million times a day for a year straight. Or if John Mieyal is correcting my math, even now, it'd be about 106 years straight. So to be able to develop a team, we're over about 90 people now, it all starts, when you're looking at your PhDs and learning how to do, this type of science. So, with that, I'll leave you with one of my favorite quotes, which is from Tennyson, which is, to strive, to seek, to find, and not to yield. So, good luck. You can do it.
Thank you very much, Tim. And now, Dr. Walter Boron, a member of the National Academy of Medicine, the chair of the Department of Physiology and Biophysics, and the executive director of PhD programs here in the School of Medicine. Walter.
Well, good afternoon. Good afternoon to our new PhD students and to the families and friends that have helped you get here. I'd like to pick up on the theme that we've just been listening to for the past 5 minutes and ask the question, why does a elite medical school like Case Western Reserve University have a PhD program? And the answer is that our medical students who are graduating in the coming year will be practicing the style of medicine that they're taught today, but the medical students of the future, and in fact the medical students graduating in 9 months from now, 20 years down the road, will be practicing a brand of medicine that we're going to create in the next several years. And this brand of medicine requires several steps to move along that pipeline. First, in the basic science laboratory, people like some of you will be doing experiments with no obvious practical application. Somebody will see that practical application and translate it to translational type science that then could eventually lead to clinical trials, which could then eventually lead to the application of those bits of knowledge or drugs at the level of clinical patients. And that's what this is all about. The National Institute of Health is trying to improve the health of human beings. And I'd like to tell you about an anecdote that may or may not lead to the treatment of a disease called stroke, the cerebral edema that occurs during stroke. And the story begins in 1988. When a fellow by the name of Peter Agre, who had trained here at Case Western Reserve University's affiliated hospital known as University Hospitals, he did his internal medicine residency here. Later on, he ended up at Johns Hopkins University and accidentally discovered a protein that weighed 28 kilodaltons. For the parents, that means that 28 units of something. And so we called it CHIP28, a not very creative name. We didn't know what the protein did. A few years later, 1991, 1992, he and his laboratory figured out that this protein, which lives in the membrane of red blood cells, is the first water channel. This is how water gets into many cells, by going through this protein that eventually became known as aquaporin-1. A few years later, another laboratory discovered a related protein called aquaporin-4. And then people developed antibodies to it in the mid-1990s and late 1990s and realized that aquaporin-4 lives largely at the blood-brain barrier. And the idea was that perhaps this is how water gets from the blood into the brain. It can cause the brain to swell, and that's called cerebral edema. And in a stroke, that can kill you. A few years later, another laboratory developed a knockout mouse in which they genetically deleted the aquaporin-4, and that they realized that in these mice that didn't have aquaporin-4, it was very difficult to get the brain to swell. Then in the year 2006, a postdoctoral fellow in my laboratory and I decided to found a company with the idea that we would do a high-throughput screen and look for an inhibitor that would block the aquaporin-4 at the blood-brain barrier. We did that screen, and we did a lot of medicinal chemistry afterwards, and eventually developed a drug called, we founded a company called Aromics, and developed a drug called Aromics 270, which is given to animals as a precursor known as Aromics 271, and it turns out it's very difficult to get the brain to swell in mice and rats. It's very difficult to kill a mouse or a rat given this drug if you have an experimental model of stroke. This is now around the year 2012. A lot of effort raising money, and finally preclinical trials are performed, and in the year 2018, the phase 1 clinical trials began. They've just finished in this past spring and summer. They were successful. Phase 1 clinical trials are safety trials, so just to know that this drug doesn't harm the patient. And next spring, we'll begin the phase 2 clinical efficacy trials, where we'll find out whether the drug actually works in human beings to stop or slow down the brain swelling that happens during stroke. It's a long story. We have probably only a 50% chance that this phase 2 trial will succeed. And even if it does succeed and things go as fast as they possibly can, this drug probably won't see the broader use in patients until perhaps 2023, 2024, if we're lucky. If you do the math, that's 35 years after the initial discovery by a postdoctoral fellow by the name of Preston in the laboratory of Peter Agre. 35 years, if we're lucky, to get from the initial discovery to the actual implementation in patients. It could, if it's successful, revolutionize the treatment of stroke, but that's a big if, and a lot of people were involved in getting from step 1 to the end. You could possibly be the next Preston or the person by the name of Peter Agre, who in the year 2003 shared the Nobel Prize in Chemistry for his discovery of these water channels. Perhaps you'll be the person at the NIH who is the program officer who helps guide this work through, or perhaps you're the person at the Food and Drug Administration who helps judge the clinical trials, or perhaps you're the writer of a scientific magazine who writes the story. There are so many careers that a PhD student can aspire to after you graduate from an elite program like this, and I put to you that you could be in a position to help science and medicine move forward in the next generation by playing a role in any of these steps along the way in the development of new drugs or new mechanisms or new approaches to the way we treat patients. So I wish you the best of luck. I look for great things from all of you, and I hope you have a wonderful rest of this orientation weekend. Thank you very much.
And now the moment you've been waiting for. Would the ushers please invite the first group of students to line up to begin the awarding of the coats. And I would like to first begin by introducing Dr. George Dubyak, Professor of Physiology and Biophysics and the Director of the Biomedical Sciences Training Program.
Again, I'd like to extend your welcome to all the guests and to the new students. These almost 100 new students are joining 16 different PhD programs, programs that are defined by different disciplines: biochemistry, pharmacology, genetics, biomedical engineering. The Biomedical Sciences Training Program is a consortium, an umbrella as it's often referred to, of 11 of those 16 PhD training programs. And the idea behind umbrella programs is that your student may be perhaps interested in cancer biology, motivated by maybe something that's happened in the family, or it could be just intellectual curiosity. But your student may be is interested in perhaps thinking about cancer from multiple avenues or methodological approaches. He or she might be interested in cancer. Well, what are the genetics? What are oncogenes? These are genes from their name that drive the initiation or the progression of cancer. She might be interested in this very new and very exciting area of immunotherapy, where you try to harness the power of the immune system to fight cancer. So being an immunologist might be a really good way of approaching cancer biology, or as was indicated in the last two talks, maybe the more traditional approach of trying to generate small molecule drugs that can be targeting different types of cancers, or the cells that fight cancer. So your student might be interested in the pharmacology PhD program. So what you're going to be hearing over the next 45 minutes or so are the representatives, the chairs, the chairpersons, and the graduate program directors of those 16 PhD programs, including the 11 with the BSTP. And you're going to be seeing the white coat ceremony. Thanks very much.
Hi, everybody. My name is Vivien. I'm one of the vice chairs in the Department of Biochemistry. To my right is Dr. Martin Snyder. He's our graduate program director and the other vice chair in the department. It is our pleasure to introduce the new students in our PhD program this year. So, the goal of the discipline of biochemistry is to understand biological processes from a molecular point of view. PhD students in our program are investigating a variety of interesting biological problems. These include cancer biology, antibiotic resistance, metabolism, neurodegeneration, RNA biology. The goals of the research are to understand the molecular basis of health, of disease, and then also perhaps to develop new therapeutics. So our first student is Cheng-Peng Pai, who comes to us from Tsinghua University in Taiwan. Our second student is Nicholas Venetos from The Ohio State University. And finally, we have Soon Yi from the Cooper Union in New York City.
Good afternoon and welcome. My name is Bob Kirsch. I'm the Chair of Biomedical Engineering, and I'm joined today by Dominique Duran, who's Associate Chair for Biomedical Engineering. So biomedical engineering is the application of engineering principles to problems in biology and medicine. Our faculty and students perform discovery research, develop diagnostic tools, and develop new treatments for various medical conditions. I'm very pleased to present our class of 29 new PhD students. So our first student is Kenya E. Alfaro, California State University, Long Beach. Sedona R. Cady, The Ohio State University. Welcome. Brett A. Campbell, Macalester College. Edward J. Carson, Case Western Reserve University. Chu-Hen Chen, Johns Hopkins University. Michaela B. Cooley, Case Western Reserve University. Simram Dayal, University of Tennessee. Lynn D., University of Iowa. Chung Ding, Johns Hopkins University. Michael S. Douglas, Case Western Reserve University. Jin Uk Hyo, Case Western Reserve University. Sa Yuen Hu, Case Western Reserve University. Brianna C. Hutchinson, University of Michigan. Jacob J. Kerner, Montana State University. Banu Prasad Kodamaraju, Jawaharlal Nehru Technological University, India. Welcome. John T. Kroll, Pennsylvania State University. Olivia K. Krebs, The Ohio State University. Danny Viet Lam, the University of Texas at Dallas. Victoria E.A. Laney, Johns Hopkins University. Suzu Lee, Duke University. Chao Lu, Boston University. Natalie N. Bueller, Louisiana Tech University. Valenteshly Pierre, Florida Polytechnic University. Shruti P. Raghunathan, Case Western Reserve University. Yeah. Zoe Sekiyanda, Makerere University, Uganda. Ananya Subramanian, Cornell University. Yue Shu, Sat Yat-sen University. Sun Yat-sen. Kevin Young, National Chiao Tung University, Taiwan. Bo Zhang, East China University of Science and Technology. Welcome. Thank you. That's our class.
Good afternoon. Welcome, everyone. My name is Hua Lo. I am the Program Director in Genetics and Genome Sciences, and I'm representing our chair, Dr. Tony Winchell-Boris. Also on the stage is Dr. Ann Matthews, who's the co-director of the graduate program in the department. She's also the director of the genetic counseling graduate program. So genetics, I think you all know what genetics is. So basically we study the genetic basis of human diseases, and we investigate how mutations in genes lead to diseases, and then try to come up with innovative ways to treat these diseases. So I'll start introducing our students. The first one is Marina Bosselman from Hillsdale College. Serena Bracey from University of Maryland. Let's see. Erin Kong from Wesleyan University. Kevin South from University of Washington. Anya Ku from Syracuse University. Ellen Hong from Cornell University. Margaret Mikachich from Ohio Wesleyan University. Joe Sachs from University of California, Berkeley. Serbia Sona from Devi Ahia Vishidilavia, India. The last student in the program is Lauren Ye from Vanderbilt University. All right, thank you.
Good afternoon. As Paul said in the beginning of the hour, this is an exciting day for faculty as well as for students. So I welcome the students and the family. My name is Alan Levine. I am the Graduate Program Director for the Department of Molecular Biology and Microbiology. The chair of the department, Dr. Jonathan Carnes, sends his regrets. He wishes the students and the family to have a wonderful day. And I will be representing him today. And joining me is Arne Riesch, one of the most popular faculty members in our department. So molecular biology and microbiology is a department, and as we heard earlier, there are 16 programs. Within our department, there are 3 programs. There is a program by departmental name, molecular biology and microbiology, a second program known as cell biology, and a third program known as molecular virology. So how do I, in 1 minute, describe 3 different programs? And the way I'd like you to think about it is we think about host-pathogen interactions. Some of us study the bacteria that infect us, such as Dr. Riesch. Some of us study the virus, such as the chair of our department, with a very heavy focus on HIV. And some of us are immunologists, like myself, who study the host response to these pathogens. It's now my pleasure to introduce the students in our program. The first is Aya Yishi from California Institute of Technology. I introduce Sarah Mason from Brigham Young University. And Brianna Bruska from Calvin College. Congratulations.
Good afternoon. My name is Jonathan Smith. I'm the director of the Molecular Medicine PhD program, and I'm joined today by Justin Lathia, who's the associate director of the PhD program. And the goal of the Molecular Medicine PhD program is to introduce medical knowledge into traditional PhD training. In order to do this, we created a brand new curriculum, and every student has a clinical co-mentor in addition to a research mentor who leads a student independent study clinical experience. We also have something relatively new we are doing in our program. We have MDs who are doing their clinical residency or fellowship who have protected time for research, and they can enter our PhD program as well. And 3 of our incoming 10 students this year are MDs entering through this program. So it's great pleasure that I want to introduce 9 of our 10 students today in this ceremony. And the first one is Takaya Brewer from Old Dominion University. Next is Jean Clemenceau from Baylor University. Haytham Elgorabli from Zagazig University. Treg Grubb from the Ohio State University. Lauren Haynes from University of Mount Union. Kristen Kay from Florida State University. Adriel Kim from University of Illinois. Marco Mergen from Baldwin Wallace University. And Adia Sapra from Banastali University. Congratulations.
Good afternoon. My name is Lin Mei. I'm the chair of Department of Neurosciences. So here is Dr. Heather Breuer, and director of our PhD program. So before I introduce our department of students, I would like to make an announcement. So Dr. Heather Breuer just received a prestigious award from NIH. So National Institute of Health, National Institute of Neurologic Disorders give out 5 prestigious awards for their outstanding mentoring each year. And Dr. Heather Breuer became one of them this year. So I will just cite one sentence for the citation by the NIH. So this award was given to Dr. Heather Breuer for dedication to superior membership, mentorship, and training in neuroscience research. And with that, she's going to receive $100,000 to support her efforts in advancing the careers of students and postdoc fellows in her lab. Congratulations. So what do we study? Very simple. We study what's in between the ears. So the brain, it contains many neurons, about the number of stars in our galaxy, and each neuron will have a lot of connections. So we study how those connections are developed and how they function. And we study how they become problematic, and that might cause neurologic disorders, such as ALS, epilepsy, and psychiatric disorders, such as autism and schizophrenia. So I would like to introduce our students. First one is Emily Arzola from Texas State University. Oscar Bautista from College of Worcester. Jessica Dartman from University of Oregon. Jessica Kinney from University of Cincinnati. Minghua Li from Peking University, China. Last but not least, Min-San Lin from Southern Medical University, China.
Hello again. I'm Mark Chance. I'm wearing my Professor of Nutrition hat and a member of the Center for Proteomics and Bioinformatics. The Department of Nutrition has a nutrition mission, which I'll talk about in a second, and houses the Transdisciplinary Center. And so our research ranges from genomics and proteomics, metabolism, through nutritional biochemistry, all the way to wellness research. We have 2 PhD programs in the department, hosted in the department, and I'm going to introduce students from both of those programs today. The first is a PhD in nutrition, which I talked about some of the research areas, and the second is a newer program in the school called Systems Biology and Bioinformatics. And there we're trying to merge both computational and experimental approaches to understand and model biological systems. Our graduate program director is Dr. David Ladowski, who's here with me and will help with the white coat ceremony. So our first student is from the Nutrition PhD program, Yu Lee Buckley from Whitman College. Congratulations. Congratulations. Now we have 4 students who are entering the Systems Biology and Bioinformatics PhD program. Philippa Blascu Tavares Piuriaria Lofish. Close. We didn't have time to practice beforehand, but we'll work on it.
You got an okay for that.
You got an okay. Thank you, Philippa. Thank you. Thank you. Our next is Joseph R. Powell from Indiana University at Bloomington. Congratulations. Our next is Jessica Scarborough from the University of San Francisco. And the last is Ru Peng Wei from Ocean University of China.
Good afternoon and welcome. I'm Cliff Harding, the chair of the Department of Pathology, and I'm here with my colleague, Dr. Xiangwei Zhu, who is director of the Pathology PhD program. First, just a little bit about pathology. Literally, pathology means the science of disease, or from the Latin, study of disease. So we are studying disease from basic science, fundamentals, and also all the way through translational topics. So that's a big set of topics in many disease areas. We have the participation not only of faculty in the Department of Pathology, but faculty in many other departments at our School of Medicine and its affiliates. In fact, some of the entering students that we'll recognize today have already chosen laboratories in the basic science departments at the School of Medicine and also at the Cleveland Clinic and University Hospitals Cleveland Medical Center. So the program in the department is actually divided into 3 training programs: the immunology training program, the cancer biology training program, which is done in collaboration with the Case Comprehensive Cancer Center, and the Molecular and Cellular Basis of Disease training program. So with that introduction, I would like to start to introduce the students. And the first student to welcome is Connor Barger from the College of Worcester. Welcome. Next is Angela DiTommaso from Michigan State University. Next is Kenneth Gallivan from Allegheny College. Next is Hannah Condolf, undergraduate work at Cornell University. Next is Adam Lauko, who did his undergraduate work at University of Wisconsin-Madison. Next is Jessica Ventura from University of Cincinnati. And next is Derek Wong, who did his undergraduate work at University of Chicago.
Good afternoon. I am John Mieyal, Interim Chair of the Department of Pharmacology, and joining me is Marvin Neiman, the Director of our graduate program. The word pharmacology is derived from 2 Greek words, pharmakon and logos. Pharmakon is translated ambiguously as remedy and poison, very apropos of what we call drugs. And logos is translated as meaning or understanding. Hence, pharmacology is the science or study of drugs. Students in the pharmacology graduate program here are immersed in exciting state-of-the-art research aimed at discovery of new drug targets and discovery of leads for the development of new drugs. Importantly, they are also schooled in the principles of pharmacology, uniquely preparing them so that they can characterize the drugs, how the drugs work in the body, and how to minimize untoward side effects. Today it's my pleasure to introduce the new students, Alexander G. Day, College of Worcester. Shinran Ging, Jinan University, China. Jacqueline Plau, University of Hohenheim, Germany. Shritel Shriram, Shanmuga Arts, Science, Technology, and Research Academy, India.
My name is Walter Boron, and I'd like to introduce our graduate program director, Professor Corey Smith. We're from the Department of Physiology and Biophysics. Physiology is the study of function, and in Chinese, the three characters that mean physiology are literally the study of the philosophy of life. And one of the characteristics of physiology is that we are very integrative. In our department, we integrate from the level of the molecule, from the atom to the molecule to macromolecular complexes to the organelle to the cell to tissues to the organ system, and indeed to the entire individual. And our department is rather unique in the world of going all the way from atom to human. Biophysics is the application of physical principles to biology, physical principles like mechanics, optics, electromagnetism, and so on. And this helps in the application of these tools to physiology. So I'd like to introduce our new graduate students. First, Solomia Boyko from Ivan Franko National University of Lviv in the Ukraine. Reza Eccles from Baldwin Wallace University. Congratulations. And Kayla Kindick from Case Western Reserve University.
Hi, my name is Jonathan Haynes. I'm the chair of the Department of Population and Quantitative Health Sciences. We actually have the privilege and the pleasure of having 3 different PhD programs. And why do we have 3 different programs? It's because one is just simply not enough to cover everything that we do. Our newest program is Biomedical and Health Informatics. And in that program, we are trying to use the massive amounts of data that are being generated both clinically and through other types of studies to really try to understand and integrate that with informatics to understand what's going on with both health and disease. Our second program is the Clinical and Translational Science program, where we both try to discover the best ways of using some of that data clinically, and also to figure out how to take that data and translate it into clinically meaningful applications with the hope that we can both treat and prevent disease. And our third program is Epidemiology and Biostatistics, and in that program we take a holistic approach to try to understand both how biology affects disease and health and wellness, and also how the social and built environments, the environmental aspects of things affect the same diseases. So we're looking at it from a 360-degree view, using both quantitative and qualitative approaches. So with that, I would like to introduce our first graduate program director, Dr. David Kalber, who's co-director of the Biomedical and Health Informatics program, and our first student, Claudia Yvette Cabrera Aviles from Case Western Reserve University. Congratulations. Our next student is Yihang Pan from Beijing University of Chemical Technology in China. Our graduate program director for the Clinical and Translational Science program is Dr. James Spilsbury. And our first student is Hussam Al-Kahatani from King Saud University in Saudi Arabia. Congratulations. And Guanjing Zhao from Northwestern Normal University in China. Congratulations. Our graduate program director for the Epidemiology and Biostatistics program is Dr. Scott Williams. And our first student is Benjamin Booker from the University of Cincinnati. Our next student is Xiying Liu from Fudan University in China. Noah Lawrence Comey from Ohio University. Abigail Curie Lenore Roche from California State University in Chico. And Jing Zhang from Fudan University in China. And I'd like to thank all the students for coming. You are the best class we've ever seen. Thank you.
Okay, the rack's empty, but we're not quite done yet. Before we continue, I would just like for everyone to stand and give these wonderful people a great round of applause. So in addition to celebrating this incoming class of PhD students, the graduate program directors last year decided they just wanted to take a few minutes to also recognize several of our more senior PhD students. In addition to being outstanding young research scientists in the lab, these young professionals go above and beyond the typical PhD student, providing leadership in a number of key areas that benefit their peers, faculty, the School of Medicine, me, and many other people in the Cleveland community. They play invaluable roles leading BSTP recruitment, organizing annual biomedical graduate student symposiums, DNA Day, all kinds of very important community events. And so I'd like to take just this moment to recognize the following Graduate Student Leadership Award winners for this year. And they are, the ones that are present here today are Leslie Cuellar-Vite, Jasmine Gajetan, Sarah Groft, Hannah Hill, Natish Reyna, Catherine Unfred Wilson, and Andrea Waxmunsky. Thank you so much for all you do for us. Thank you. Okay, we has started this in our second Seeds of Discovery. We began this tradition in 2014, and this tradition is that the final speaker in this ceremony is one of you. It's one of your own. Each year, we select a student that went through last year's Seeds of Discovery to close the ceremony. Jean Moon received her BS in Biology from the University of Virginia the University of Virginia, and it's a master's from Virginia Commonwealth University. She is currently working in Dr. Johannes von Lichtig's laboratory. I thought I saw him back there. And in the Department of Pharmacology. Ladies and gentlemen, Jean Moon, a second-year PhD student in Pharmacology PhD program.
Successfully got up here, so I just have to be able to get down without falling. Okay, so good afternoon. It truly is an honor and privilege for me to welcome you all to the Case Western Reserve University's Biomedical Graduate Program. I hope that everyone has had a chance to celebrate reaching this very important milestone. As you have seen, you have come from all over the country, and for some, around the globe. Each of you has a unique background, a unique experience. However, you have all reached this point because you are hardworking, you're creative, you're ambitious, you're independent, you're tenacious, and a bit curious. And we are all excited for what you will bring to our community. So welcome. Now, this ceremony is a bit distinct from other welcoming ceremonies that you have probably been to. Likely, they have began with, welcome, class of, but we all know that there is no cookie-cutter response to our graduation dates, and this will come up pretty often. When I introduce myself as a PhD student, the most common question I get is, oh, so how many years is that going to take? And yes, we live in a culture where it is a race against time. We're looking for faster communications, how to faster and get quicker data accumulation, how to get faster publications. And yes, we can all agree that time is precious. However, we are here to ask questions that we may never be able to answer. As Albert Einstein once said, it's not that I'm so smart, it's just that I stay with problems longer. And true scholarship and knowledge pushes us to dig deeper and to learn more and to develop a more complete and accurate story. But I am pretty sure that you are already aware of the commitments that are brought upon when starting a PhD. If you're anything like I was in the beginning, you have many mixed emotions and many questions. Am I choosing the right labs to rotate in? What are the potential questions that I should be asking my mentor to be? And having just completed my first year, I would like to share a few things that I have learned that I hope will help you in the months to come. So 1, you will not know what is going on in the first few months. And this is okay. Most of us come into lab knowing a few techniques up our sleeves. We have our fundamental knowledge from undergrad. And however, there will be methods or topics that you are not familiar with yet. And when that happens, just ask, even if that means delaying a task. And this is totally worth it. There are times when I will spend days or weeks trying to figure out something by myself, only to have realized later that if I had just asked a postdoc in the lab, they would respond with, oh, the trick for that is. So never assume, ask. And that leads me to my next tip. It is truly okay to accept and say, I don't know. So say you're in a meeting or a presentation and they ask you a question that you simply don't have an answer to. And this will creep up a lot, especially when you're trying to start up your project. Initially, you may feel a bit overwhelmed, and then doubt starts to creep in. But be able to come to grips with doubt. Respond with, I don't know, but let's find out. Now, this does not mean that you shouldn't be spending time to conduct your own literature searches. Set up an automatic PubMed email alert on the topic of your project. 3, adapt and evolve. You have just spent endless days creating what you think is a perfect project plan with very clear aims and objectives. And then your PI or your peers have one look at it, and then the whole fortress just crumbles down. Accept being wrong and don't forget that it is constructive criticism. Reformulate your hypothesis. By knowing what does not work, you can narrow down and focus on the parts that do. 4, take full advantage of your rotations. And when choosing a lab, remember that the mentor is more important than the topic of the research. I came in with a very specific idea of the type of research and the area of research that I wanted to do in grad school. However, your PhD is a time where you want to learn how to ask better questions, how to develop and design a better experiment, how to critically analyze the data, and then be able to clearly communicate those results. A good mentor will guide you through those skills. So don't slack off in any of your rotations, and take the time to learn a new skill or build a relationship. A mentor is not necessarily your PI only, but also a person that could potentially be on your committee. And finally, 5, work hard and rest hard. Honestly, I'm still working on the rest hard part. There will be times when you have to come in on the weekends, yes, to develop that Western blot. But invest in yourself. Find a de-stressor, join a club, find a friend group. The people you're sitting next to right now can be the best friends you commiserate with, but also apart from the social aspect, they will become your best scientific colleagues. Now, I would like to end with the significance of this white coat ceremony. Some of you will end up working in a lab where you'll be behind the computer to develop novel statistical or computational methods, and you'll never need to wear a lab coat. In the late 80s, white lab coats had demonstrated a new generation of medicine that was rooted in scientific principles and knowledge. White had symbolized purity, respect, and professionalism. So whether or not you don on a lab coat in the future, be reminded of your commitment and responsibilities of upholding your rigor in your science. You are here to drive discovery, and I look forward to joining you on this endeavor. Congratulations and good luck to each and every one of you.
Okay, before we begin our procession out, I just really wanted to very quickly acknowledge a few individuals who were instrumental in putting this together. First and foremost, the dedicated staff of the Graduate Education Office that includes Debbie Nordine, Grace Filar, Rissa T, and a huge effort in organizing this whole thing goes to Ms. Milana Bay. If you see her out there or any of them, please let them know how much you appreciate this. The students of the Biomedical Graduate Student Organization, we cannot function without you, and so we are so much indebted to you for all you do for us. Of course, our dean who supports this whole thing, Pamela Davis, she's always been supportive of this event in the beginning of it, so thank you to her. And I wanted to thank all of our past graduate students and current graduate students that are joining us today. We are going to begin the procession out. We will head out the door and into the lawn to take pictures. Guests, please help yourself into the very back area to pick up some good bites and eats, and they will clear out a little of these back rows of seats. So please move to the back as we leave the auditorium, and that'll help us clear out so that we'll have more room in here. Thank you very much. Guy.